Atoms and the void. This was the simplistic view of the world as it was at the end of the 19th century. It exists now only in the imaginations of naive realists. What we now know is that at some point in the early 20th century the foundations of physics were shaken in a revolution that gave birth to quantum mechanics. Eventually, this shocking new picture of matter would end up causing us to reject the atoms of Democritus altogether. But what of the void? Though successful, quantum mechanics was not without its critics. Most noted among these was none other than Albert Einstein himself. In 1935, Einstein, along with two colleagues, Boris Podolsky and Nathan Rosen, posed a paradox to refute quantum mechanics. Their thought experiment was to place a pair of particles into joint superposition, such that a measurement of one would instantaneously cause a change in the other. However, if these particles were separated over a distance, then Einstein deduced that the second particle would be affected instantly by what he termed a spooky action at a distance. At the time, it was believed that science depended on locality, and this voodoo doll-like effect violated it. Thus, Einstein and his colleagues believed that this would falsify quantum mechanics. However, in 1982, the French physicist Alain Aspect put this thought experiment to the test. His result is what we now refer to as quantum entanglement. As it turns out, Einstein's spooky action at a distance is real after all.
Two objects, two electrons created together, are entangled. Send one to the other side of the universe. Now, do something to one, and the other responds instantly. Instantly. So, either information is traveling infinitely fast, or, in reality, they are still connected. They are entangled.
But locality is not the only thing at stake. Entanglement has consequences for space as well. The notion of space only has any meaning in distinguishing between the locations of two objects. However, before measurement, quantum mechanics tells us that the particles in the entangled system have no defined locations with respect to each other. In fact, before measurement, they have no properties whatsoever.
There's another theorem which is called Koch and Specker theorem. It's much less known. And that theorem tells us that the culprit is actually our notion of reality. We know that it is wrong to assume that the features of a system which we observe in the measurement exist prior to the measurement.
Since the properties in question are the locations of the entangled particles, the space between them does not exist. But the implications of this are not merely contained to the specially prepared quantum states in the laboratories of physicists. The precise definition of entanglement is that two or more particles share the same wave function. However, on the grandest scale, everything in the universe ultimately shares one wave function. In other words, everything is ultimately entangled. But what does this mean?
That means everything is still touching. Space is just the construct that gives the illusion that there are separate objects.
Space, it seems, exists only in the eye of the observer.
The space doesn't exist. I describe world without space using models.
All right, now we're going to go to the really big guns. Albert Einstein, of course. I'm going to read you a few quotes from Albert Einstein. These are quotes toward the end of his career where he had been working on his unified field theory for about 20 years. At this point, he had come to some very solid conclusions about where the answer lay, but he just couldn't get there. One of his conclusions was that space does not have an independent existence. Now, that's pretty profound. Space does not have an independent existence, he said. Reality is merely an illusion, albeit, he said, a very persistent one. He says, hence it is clear that the space of physics is not, in the last analysis, anything given in nature or independent of human thought. It is a function of our conceptual scheme. Space is a function of mind. Space is conceived by Newton, proved to be an illusion. There's one from Einstein, written back a letter to David Bohm. It said, one has to find a possibility to avoid the continuum together with space and time altogether. but I have not the slightest idea what kind of elementary concepts could be used in such a theory.